Today we're going to start our discussion on sequences and series. So again, I'm going to have a couple definitions. So a definition of a sequence is a function whose domain is a set of consecutive integers. So that's going to give us our x-axis. So our x-axis is going to be 0, 1, 2, 3, 4, 5, and 6. The values are in the range are called the terms of the sequence. So that's going to be our y values, which remember are the range. So let's take an example of a sequence. Let's take an example of something maybe you can recognize. 1, 4, 7. See if you can find the next couple of terms. And these are called terms. Typically we say that this is the first term, n equals 2 is the second term, n equals 3 is the third term. And when we graph these, we graph the first term is 1, the second term is 4, the third term is 7, and we graph a sequence with dots and do not connect them. And again, the reason why we cannot connect them, when we have a connection, if I had a line here, then that would imply that we'd have a 1.5 term, and we don't. We simply have a first term, second term, third term, and fourth term. A sequence that is finite stops. In other words, it has a finish to it. An infinite sequence goes forever. Now when we're asked to find a pattern, sometimes it's easy to find the pattern and sometimes it's not quite so easy. So today I'm going to ask you to find a pattern. So we just look at the numbers 2, 5, and 8, and we might see that they differ by 3, so we're going to just add 3 to the term. 5 goes up to 25, goes up to 125. I'm not sure you see the pattern, but there is something special about 25, and there is something special about 125. So then the pattern might become a little easier to see. And you'll probably use your calculator to get these values. Take a second and see if you can see the pattern for the next two examples. We have 1, 1, 2 2s. So the pattern would be we have 4 4s next. The next example, you might see the bottom is always one more than the top. So we go 4 and a 5, 5 and a 6, a 6 and a 7. And again, tomorrow we'll look at how we can tell the exact patterns, but today I just want you to get a feel for what a sequence is. Sometimes when we're asked to find a sequence, we're giving a formula, and this N stands for the term number. So to find the first term, the second term, the third term, and the fourth term, all you do is simply plug in N equal 1, 2, 3 and figure those out. So if I put a 1 in here, I'll get a 2 plus 5, I'll get a 7. If I put a 2 in here, I'll get 4 plus 5 is a 9. And then if I put a 3 in here, I'll get an 11. And about this time, you probably see the pattern, and you can use the rule or the pattern, either one. When it's a value like this, again, we always still go N as 1, 2, 3 for first, second, third term. So -1 to the 1 minus 1. Anything to the 0 power, remember, is 1. If I stick a 2 in here, I'll get -3 to the first power, which would just be -3. When I stick a 3 in here, be careful, I'll get a negative 3 squared, which will be a positive 9. And the fourth term, I get negative 3 cubed, which will be a negative 27. So hit pause and try to do example 2, and then I'll have the answers up. How did you do? 1 goes 5 minus 1 is 4. 2 is 10 minus 1 is 9. 3 is 15 minus 1, and again, you might see the pattern. For part B, put in 2 equal 1, 2, 3, 4, 5. So again, n equals 2 minus 3 is negative 1. 2 squared minus 3 is 1. And you simply plug in n equaling 1, 2, 3, meaning first, second, third term. To find the rule, you look for patterns and see if you can write what those patterns are. So again, sometimes these are easy to see, sometimes they're kind of hard to see. If you recognize these as perfect cubes, but they're negative, so this would be a negative 1 cubed. The next term would be a negative 2 cubed, negative 3 cubed. So the rule, we would write an A with a little n next to it. And what are we doing? We're taking that n value and cubing it. So see if you can, in part B and in number 4, see if you can see a pattern, and then I'll try to show you how that pattern might be. And I think actually part B is the easier one. So in letter B, I saw that 1 squared minus 1 is 0. 2 squared is 4, minus 2 is 2. 3 squared is 9, minus 3 is 6. 4 squared minus 4 is equal to 12. So how would I write that? I'd write that n squared, because remember we're taking n equal 1, 2, 3, minus n would be my rule. And again, these are kind of tricky, so I saw that this difference was 3, 5, 7, so I knew I couldn't write it kind of as a difference, but I saw that 1 squared plus 1 is 2, 4 plus 1 is 5, 9 plus 1 is 10, 16 plus 1 is 17. So the rule I wrote here was n squared, but the n squared is always plus 1. In part B, I saw that negative 4 was times 1, negative 4 was times 2, negative 4 was times 3, negative 4 was times 4, and so forth. So my rule would be negative 4, and look at your 1, 2, 3, 4, and that's your n. So I'll give you a worksheet on this. Putting up the rules, that'll be the hardest. Finding the sequence, all you have to do is put n equal 1, 2, 3 into your sequence, and you'll find those values.